Problem number 31, evaluate the radical function. So right here we have our radical function, and then it says find f of -1, f of 0, and f of 4. So remember, usually it says f of x, so that means that all these values that are here in parentheses are x values. So what we do is each individually we will plug them into the function. So let's start with the first one by plugging in -1. We are not calculating anything on the left side. This is just saying the function when I plug in -1 for x. So -1 plus 5. And then we are continuing to solve the right side. So -1 plus 5 gives me 4. And then I actually can take the square root of 4, which is 2. Alright, so when x is -1, then f of x, or f of -1, is equal to 2. Now let's plug in 0 for x. So when f of 0 is equal to, my x value now is 0 plus 5. So I get the square root of 5, which is not a perfect square, so I'm just going to leave it like that. And then my last one, now my x value is 4, so when f of 4 is equal to the square root, and I have my x value, which is 4 plus 5. Okay, simplifying under the radical, we get 4 plus 5, which is 9, and 9 is actually a perfect square root, so the square root of 9 is 3. So my answers for this first part of the evaluate problem would be 2, square root of 5, and 3. In the next part of the problem, we are given a different function. So now we have g of x equals the cube root of x plus 2. And we are given different function values. So here we are finding g of 3, g of -10, and g of 25. Again, all these numbers are the x values that we will have to plug into the equation. So starting with the first one, g of 3 is equal to the cube root 3 plus 2. Solving the right side of the function, we get the cube root of 5. 5 is not a perfect cube, so it's fine to leave it like that for the purpose of evaluating the function. Now let's plug in -10 for x. So g of -10 is equal to the cube root -10 plus 2. Solving the right side, we get the cube root of -8. Now, -8 is a perfect cube. There is a number that you multiply 3 times by itself to get -8, and that would be -2, because -2 times -2 times -2 is -8. And then my last problem for this function is plugging in 25 for x, so g of 25 is equal to the cube root of 25 plus 2. Solving the right side, we get the cube root of 27, and 27 is a perfect cube. The number that's 3 times multiplied by itself to give me 27 is 3. So my answers for this part of the problems are the cube root of 5, -2, and 3. Now in the last part of the problem we are given the function h, so it says h of x equals the fourth root of x minus 3, and then we have the function values h of 19, h of 5, and h of 4. So these are x values, and we are going to plug them into the function starting with h of 19, and we get the fourth root of 19 minus 3, solving the right side, the fourth root of 16, and 16 is actually a perfect fourth root. The number that is multiplied by itself 4 times would be 2. Now h of 5, plugging in 5 for every x value in the function, and we get the fourth root of 5 minus 3, solving the right side, the fourth root of 2. Now 2 is not a perfect fourth root, so it could just stay like that. And then we have h of 4. Plugging that into the function, we get the fourth root of 4 minus 3. That gives me 1, and 1 is actually a perfect fourth root. The number that's multiplied 4 times by itself to give me 1 is just 1. So the solutions to this problem would be 2, the fourth root of 2, and 1.